Right. The term linear pair specifies a pair of adjacent angles that form a straight line. So in this case, angles 1 and 2 are considered a linear pair. And the relationship, because they form a straight line on this, is, in this particular case, angle 1 plus the measure of angle 2 together add up to what degree measurement? By their definition, a straight angle, which is 180. And so this relationship right here can be described or justified by the definition of a linear pair. Okay, so anytime that you want to make the statement that a pair of adjacent angles that form a straight line add up to 180 degrees, okay, you will defend that by stating definition of linear pair. Okay, so again, this is one of those first principles. It's something that's part of the definition, kind of built in. So as far as the types of problems that you might see is if I told you that you had this linear pair and the ratio, let's say, was, let's call it angles 3 and 4. If I say that the ratio of angle 3 to angle 4 is 7 to 2, find each angle. And so how would you set this problem up? Okay, good. So one way when you're looking to solve using ratios is to know that 3 is 7 times some common multiplier, x, whereas angle 4 is 2 times that same multiplier. Again, you don't know what the multiplier is, but what do you know about these two angles? Together they have to add up to 180 by definition of linear pair. And so when you solve for this, you get 9x is equal to 180. So what does each x represent? 20. So is your answer 20? Is your answer 20 and 160? No, but be careful when it comes time for the final, okay, and you have like distractors, multiple choice questions where only one of them's the right answer. I can guarantee if I gave you this problem on a final that 20 would be one of the answer choices, okay, because as you're working through it, you come up with that answer. So if you see it on the sheet or on the test, you might be tempted to say that that's your answer. Be very careful and complete your question before you answer it. Okay, so if I take this and I complete it, 7 times 20 is 140. 2 times 20 is 40. Does this fit the conditions you would expect? Are 140 and 40 a linear pair? Yeah. Okay, so here's one way that you can solve it. You can represent them. Okay, this method is looking at the ratio as part to part. You're maintaining the ratio that this is 7 parts to this one's 2 parts. So 7x plus 2x is equal to the whole. Okay, so you're still relating it to the part or to the whole, but you're relating it as the part to part. And now, anytime you're dealing with a ratio, you can always convert from part to part into part to whole. Okay, and here's what I mean by that. If you have 7 parts and 2 parts, then this angle 3 is what fraction of the whole thing? It's 7 out of how many total? If there's 7 parts here and 2 parts here, the total is how many parts? 9. So angle 3 is 7/9 of the whole thing, and angle 4 is what fraction of the whole thing? 2/9. So if you think in terms of part to whole ratios, so if you convert a ratio into its part to whole fraction, what you can say then is angle 3 is 7/9 of the whole thing, which you know is 180. Angle 4 is 2/9 of the whole thing, which is 180. And so you can still solve this problem kind of the same way. 9 goes into 180, 20. 20 times 2 is 40. So you can get this angle as 40. 9 goes into 180, 20. 20 times 7 is 140. So it doesn't matter which way you think of these. I'll be coming back to this concept of converting part-to-part ratios into part-to-whole So I just wanted to introduce it here to start with.